I welcome you all for this presentation. In this presentation, we are going to discuss implementation of linked list. In the last presentation, we discussed about the introduction to linked list. This is the overview of this presentation. What are the various operations we can perform using linked list, then creating a list, then traversing a list, then insertion of node in a list, deletion of node from a list, followed by summary of this presentation. These are some of the operations we can perform in a linked list, basic operations. In addition to this, we can perform any more operations like concatenation, sorting. Then we can use this linked list to implement the stacks, queues, many more things we can do. But these are the four operations or the very basic operations we can perform in a linked list. So in order to perform operations on linked list, we have to create a linked list. So the first operation is creating a list. Next is traversing a list. What are the elements in the list? We are just displaying it or printing the contents of the list. That is traversing a list. Then insertion of node in a list. In the last introduction to linked list itself, we have discussed that how we have to perform insertion in a list. There are three ways to perform insertion in a list: in the beginning, middle, as well as at the end. Likewise, we can perform deletion of node from a list also. For deletion also, we can perform in three different ways. That is in the beginning, middle, as well as end nodes we can perform deletion. So insertion and deletions we are going to discuss with respect to three different ways. Creating a list, it is simple only. Then traversing a list. First is creating a list. Now we are going to create a list. So in order to create a list, we need to think what is the structure of any node. And we are all aware that in any node, we are having two compartments. One is for the data and another is for the pointer. That is next node's address we have to store. So two compartments are there in a linked list. We all are familiar, and in the introductory class itself we have seen the one is for the data and another is for the pointer. That is next node's address is stored here. So here first we have to create a structure of a node. So in the structure of the node, here we are having int roll number. Here data in the sense not only one data, we can have many more data also, like roll number, name, age, likewise. So a roll number, then name, then age. Then we are creating a pointer. These are for the data part and these are for the this is for the next node. That is it. Next node's address we have to store. It is a pointer. So only this struct node star next. Already in the stack implementation we have seen about what is struct. It is a keyword. Then what is the name, structure name we are giving. All those things we have seen. So here we are going to define a user defined data type called node, and the type of that node is a structure type, that is struct node. So we are defining, that is we are typecasting or we are type definition, we are defining struct node as node. So wherever we want this node representation, we have to write only node. So what is the meaning? It is a structure. It is a structure that consists of these things, data as well as pointer. And in the data, it is not necessarily that only roll number alone or name alone must be there. We can have multiple elements also, no issue in that. Then we are declaring the nodes as store head. We know that initially we need a head pointer. So only here we are declaring node head as a node type, because here we have defined the type of node. So now we are defining head as a type node. It is a pointer. So only here we are having a store. Then we need to allocate memory for the node. That is very, very important. Here in the linked list, dynamically the memory is allocated. So here in the implementation of linked list, we have to understand two things, and we must have the prerequisite of two concepts. One is the pointer and another is the dynamic memory allocation. And in the previous programs itself, some of you have used this malloc function. So I think all of you are aware of that. Some of you are not aware, means also no issue. Already you have learned this pointers as well as dynamic memory allocation in programming in C in our curriculum itself. So please brush up those concepts, then it will be very much comfortable for you here. So here to start with, we have to create a node. That is the first node we are going to create and make head point to it. What is head? Already we have declared the head variable, that is a pointer variable of type node. So head equal to node star, because the head's type is node. Then node consists of struct student details, right? So node star malloc size of node. Here node in the sense we are having an integer. Integer needs 4 bytes here. Then another thing, we need a pointer for 64-bit compiler. We need 8 bytes for the pointer. So likewise for each and every data item, whatever the required memory storage we require, those things we are just allocating. So it is size of the node. What is the size of the node? We are just allocating. Not only 4 bytes and 8 bytes, we are having many more. 2 integers are there. So 4 plus 4, 8 is there. Another one item is also there. So what is the requirement for that storage capacity we have to look into. Then automatically it is allocated. But for our understanding, we have to know how many bytes are required. That's all. But if you are writing this line of code, it will automatically assign the space for this particular node. So here you see we are having a head. Then this head is pointing to the first node. First node consists of roll, number, name and age. And we are having the second compartment as next. This consists of the address of the next node. Then if there are n number of records in the initial linked list, what we have to do is we have to allocate n records one by one. So one by one we have to get roll number, name, age. Then for the second record, roll number, name, age. Likewise here we are having 3 records in this sense. For the 3 records we have to get one by one. And read in the fields of the records, then modify the links of the record so that the chain is formed. So this is the code for creating a list. So here we are having a node. Node we already know it is a node is a node star create list. Node is a type, right, of a structure student node star. So node is a type. Star create list of, it is a name. So you can give any name for this. This is a pointer. So only here we are having a star. And we are whatever the variables needed we are going to declare here. So here we are having int k comma n, that is go get the number of elements. Then for incrementation purpose and all we are having these variable names. Then we are having 2 more variables called p as well as head. So p and head of type node. Then we are just asking the user that how many elements we are going to enter. So n elements means we are getting the n elements one by one. And for each and every element we are getting one by one. That only we have seen in the previous slide. So for k equal to 0, instead of k you can give I also, no issue in that. K equal to 0, k less than 1, k plus plus. And if k equal to 0, because it is a head node. If it is a first node, what we have to know? Head equal to node star. For head we are assigning node star malloc size of node and assigning the head to p, because this is the first element. So first element only p. So we are assigning the first node head points to the first element. Else if this condition is not true, then what we are doing is p points to next equal to node star malloc size of node and p equal to p points to next. Then what we are doing is we are scanning each and every value for all the node. So only here you see this if is ended here, else part is ended here, this for is ended here. So for the first node we are just getting all the element. For the second node we are getting all the element. Third node we are getting all the elements. Suppose n equal to 3 means for 3 nodes we are getting all the elements. Then p point to next equal to null, because initially we are creating a list and at the end the last node p points to next equal to null and we have to return the head. This is the code for creating a linked list. So how we have to call this function in the main means head equal to create list of. So because in the previous code, that is create list of function, it returns the head, right? So head equal to create list of function is called, and the created list is signed. Next operation is traversing a list. We all know that traversing a list means in order to display the contents of the list, one by one we are traversing, then we are just printing or displaying the contents of the list. That is traversing a list. So once the linked list has been constructed and the head points to the first node of the list, what we need to do is we have to follow the pointers. Then whatever the pointers we are having, that we need to follow it, then display the contents of the node as they are traversed. Then we have to stop when the next pointer points to null, because the last node is null. From first to last we have to print it or display. So stop when the next pointer points to null. So this is the code for traversing a list. Here we are having a function. This function is not returning anything, so only it is void. If it is returning any node or something, means here we have to mention it. Here void means this function is not returning anything. So void display of what parameter we are passing is, already we are having the node star head we are having it. That parameter we are passing it. So because the list only we are going to display, so the list we are passing it. Here in the count equal to 1, then node star p. So p is a pointer of type node, and first we are assigning head to p, and if p not equal to null, what we are doing is we are just printing it. Roll number, name and age. Next we are incrementing the count. Then p we are just writing p point to next is assigned to p. Likewise, we are printing all the elements in a linked list. This is about traversing a list. And how we have to call this function in a main function means display of head. Because this function does not return anything, because void display of only we have given. So if it is not returning anything, no need to assign this function to some other name. Here simply we have to call it to display the linked list. Next is insertion of node in a list. So in order to insert a node, what we need to do is we have to insert a node before a specified node. You already know that if we are going to insert in the beginning or at the end or at the middle, so anyway we have to specify a node, we have to insert a node before some specified node. In the beginning means also currently one linked list is existing. In that existing linked list, before the first node we are going to insert. That is the meaning. And at the end means there is nothing. So whichever the pointer we are having null, that only we are considering. So here what we are needing is specified node means some value is given for the node. And in our example we are having 3 elements in one node. So we have to consider any one of the element as a key. And here we are considering the roll number as a key. So what convention we are following in our code is, if the value of the roll is given as negative, then the node will be inserted at the end of the list. Because already we have to know from which node we are going to insert before the specified node. So after node we have to know anyway. But if you are inserting at the end means there is no after node. Null is there, after node is not there. So what convention we are following for that is, if the value of the roll is given as negative, then the node will be inserted at the end of the list. This is very, very important. You need to consider here. So when a node is added at the beginning, what we have to do is, we only one next pointer needs to be modified. At the beginning means only one next pointer only we needs to modify. That is, head is made to point to the new node. Say for example, head is there and the first node is there. Now we need to insert here only, because the specified node is this one, roll number equal to 10, say for example. So roll number equal to 10 we have to, before roll number equal to 10 we have to insert. In such a case, what we need to do, head is made to point to the new node. Here only we are going to insert some new node. So in order to insert a new node, what we have to do, this is a new node. So in order to insert that, here this head pointer, head is made to point to the new node. Head pointer we have to made to point to the new node, and the new nodes, the next pointer points to the previously first element. This is the way to insert any node in the beginning of the list. So this way we have to insert. And if you want to insert any node at the end, means what we need to do is we have to modify two next pointers. That is, the last node now points to the new node. Say for example, here we are having a list like this, and at the end we are going to insert. Now it is null already. So last node now points to the new node, because after this only we are going to insert. So the last node points to the new node. So this last node now points to the new node, and new node points to null. So now this becomes the null. So this way only we are inserting element at the last. And if it is in the middle, what we are doing is two next pointers need to be modified. What are the two next pointers? This I want to remove it now. Insert it. I want to insert between this node and this node. Here I want to insert. So at that time what I have to do? The previous node now points to the node. This is the previous node and this is the next node, right? Now, so this previous node points to this new node and the new node points to the next node. So previous, this is previous and this is next. So while interpreting the linked list and in the implementation point of view, you have to know this is the previous, this is the next. So what we are doing? First we have to make the previous node points to the new node and new node's next points to the next node. This way only we have to do. So in with respect to insertion, with these three cases we have to perform insertion. Let us see the code. So this is the code to insert a node. Here void insert of node star star head. Why it is star star head in this sense? It is a pointer to pointer concept. Simply one address we are storing means no issue. It is a pointer, but here we need to know the pointer to pointer concept we need to know. So here the variables, all those things we have to initialize, then declare, all those things we have to do. And why here we are having the roll number is with respect to the specified node only we are doing. So the specified node how we are assigning is with respect to roll number only we are assigning. So here we are having three variables of type node, all are pointer variables. Star P, star Q and star new. Because always we need to know two things, two pointers we need to understand. In between we have to insert. Deletion means also we need. All those things we need. So only here we are having this P, Q and new. New is for the new node other than previous and the next. P is for the previous and Q is for the next. So in order to insert a node, that is a new node, right? New node only we are going to insert. So we have to allocate space for the new node. In order to insert any node, we have to allocate space for the new node. Because existing linked list, it is correctly occupied by all the available nodes. And if you want to insert any new node, we have to allocate some space. So here new equal to node star malloc size of node. Already you know this. It is to create a new node. Dynamically we have to allocate space for the new node. For that only we are having this line. Then printf data to be inserted, and here for one node we are having three elements. So we are just doing ampersand new point to role, new point to name and new point to ampersand new point to age. Then insert before roll number, negative for the end. If you want to insert at the end, if at that time you have to specify the negative value. Scan percentage the roll number, because why we don't know, we are just giving negative means if it is a last node, after last node if you are going to insert, what happens, we don't know that specified node, because this is the last node, we don't know the specified node. So in order to interpret that only, here we are giving that negative for the end. Then we are assigning star head to P. And if P point to roll equal to roll number at the beginning, if you are going to insert, then we are assigning this P to new point to next. Because what is this P? It is a head pointer. And this head pointer we are pointing to, we are assigning this P to new point to next. Then we are assigning new to this star head. So now we inserted at the beginning of the list. The new node is inserted at the beginning of the list. Else, if it is not at the beginning, then while P not equal to null, P not equal to null and P point to roll number not equal to roll number, these two conditions are true, that is this negative conditions are true, what we are doing is, we are just assigning P to Q, then we are assigning P point to next to P. And if P equal to null, at the end we are going to assign means Q point to next equal to new. The last nodes next point is we are assigning the new to the last nodes next. And what is the new point to next? The last new nodes last, it is null because we are inserting at the end. Else, if P point to roll number equal to roll number in the middle before a specified node we are going to insert. In such a case, we need to know that P and Q position we need to know. Here the pointers Q and P always point to consecutive nodes. So Q point to next equal to new. Here if you are going to insert in between these two nodes means this is Q and this is P. This way you have to consider. So we are assigning the new to Q points to next. We are assigning the new to Q points to next. And new points to next is we are assigning P to this P to new points to next. So this way only we are performing insertion in all the three places. So how we are calling this insert operation in the main function means insert of ampersand head, because this insert function doesn't return any value. So we are not assigning to anything. Simply we are calling insert of ampersand head. Next is deletion of node in a list. So here also we have to consider the same condition what we discussed in the insertion part. So here what we are doing is we are required to delete a specified node only. So how we are mentioning that specified node with respect to the roll number field. Here also we need to consider three conditions: deleting the first node, deleting the last node and deleting in the middle, that is the intermediate node. So these three conditions we have to consider here also. Let us see the code. Here you see that void delete node star star head. Here also pointer to pointer concept. Here we are declaring the needed variables, roll number of type int, then P and Q for the node, and we are what roll number we are going to delete. We have to ask from the user. So scanf percentage the roll number. Then what we are assigning, the head is assigned to P, and if P point to roll equal to roll number, then what we are doing is, this is the deleting the element in the front, that is delete the first element, that is the meaning. So P points to next is assigned to the head and we are just freeing off this P. You are just freeing off P. So this is a function. Already you have to know it is a built-in function. Free off is a built-in function. It is to free the space allocated for a node. So we are just freeing off the P. Else, if the condition is not satisfied, then we are checking the condition that P not equal to null and P point to roll number not equal to roll number. Same condition we checked in the insertion part also. If this condition is true, then we are assigning P to Q and P points to next we are assigning to P. And if there no element is found means we are just telling that deletion failed. And if this condition is false, that is P point to roll equal to roll number, if you want to delete any other element, what we have to do is, that is in between, if you want to delete means P point to next is assigned to Q point to next. Then we have to free this P. That is in between, if you want to delete any element means we have to do this one. So that's all about the basic operations. So in this presentation, we discussed about 4 important operations on linked list, that is creating a list, traversing a list, insertion of node in a list, and deletion of node from a list. Thank you.